GM. Welcome to Solo Dev Stack. So in this series, we are not going to be building just a decentralized application. We are going to be building a Supra decentralized application with the Supra Move programming language. So this is going to be exciting, and this video is suitable for whoever has a good fundamentals in programming. Regardless of your programming language, this video is for you. This is the Supra IDE. So it entails a lot of features such as testing, deploying, and actually compiling your smart contract inbuilt without writing a single command line. So let's take a talk. So to access the IDE, you go to ide.supra.com. I'm going to drop the link down the description. So immediately you open the browser, it will automatically creates a wallet which has an empty balance Supra. And here is the wallet address. You can copy it whenever you like. And if you like, you can connect your external Stacky wallet. You can also create other. So you can also create other wallets by clicking the button Add Wallet. So these local wallets can be created locally on your machine. So you don't have to go and write. So you don't have to write any command to create wallet. So here is the home page. You can actually go to the tutorials to see more about the Stacky. So you can actually go to the tutorials to see more about the Supra IDE. So here is the Explorer, and we're going to come back to you shortly to create a program. So here we'll see the list of all the transactions we are going to make, and here we can write functions. We can see the functions we deployed here, and we can also run functions from here as well. So here we can choose to export our code in zip format. We can choose to import a file, and we can accept few sets from this button. So we can accept few sets from this button, and we can also go to the Git book to read more about the Supra IDE. And also here we'll see the network in which our account is on, which is our wallet. So now let's go to our Explorer. So just click. So we're going to click create a new project to create a new move, to create a new Supra Move project. So we're going to call this voting contract. So you can choose to go with a template, either Hello blockchain, stablecoin, or Mooncoin. So let's just create our project. So we can see our project has been created. So we can see the compile. So here we can compile our code. We can test our code as well, and also we can deploy our code in the Supra IDE. This is amazing. We have to go through a lot to actually achieve this, but Supra is all about automation and simplicity, fast and efficient. So here we can see our wallet has already been added as the owner of the we can see our wallet has already been automatically added as the owner of the program. So we're going to change this to election board, since we are going to be building an election application. Since we're going to be building an election application, we're going to call this election board to be in charge of all the application that we are going to. So we're going to call this election board, which is going to be the owner of the contract we're going to be creating. So this program is going to be reusable. Everyone can come to the platform to create his own election, and it's going to be amazing. Let's go on. So yeah, we're going to call the address election board. So we can So we'll go to our sources file and create a file called um let's call it voting underscore contract contract dot move. So yeah, we're gonna start by writing our module. So we'll call it module. So when creating the Supra move contract, you have to start by writing the syntax module. You can see how amazing the IDE is. Um it shows you the functions or whatever you need. So now we'll write the name of our wallet here. The name of the wallet we wrote earlier, which was election board. So we are telling the Supra contract that we want our program to be stored in that wallet. So call it voting contract. So yeah, um yeah, so now we're gonna start by importing all the necessary modules we are gonna need. So we're gonna need the string. So we're gonna need the signer from the standard library. So signer. Signer, we're gonna need the string. We're gonna need the string use std string. Next, we're gonna need um yeah, we're gonna need next we're gonna need uh next we're gonna need next we're gonna need an option from the standard library as well. We're gonna need a vector because we're going to be storing. We need a vector. We're gonna need, yeah, for now we can go with this because these are the basic things we need. So yeah, we can go on. So we're gonna start by declaring a structure, also known as struct. I'm gonna explain what a struct is in a moment. Election manager has key. So a structure is like a state in which so a structure is like a state in which we store our data in. So when we use it, you're gonna see how it's being used vividly. So the hash key is an ability that tells our contract that we want to be storing this globally and the blockchain. So it's not going to be droppable. We're going to see what a drop ability is, a copy ability as well. So in our election manager, we want to have the total created election, total created election, or we can make it use 16. Next, we can have the elections, sorry, elections. This is going to be the individual elections in our this is going to be the individual elections in our program. So it's going to be a table. So shortly, I'm going to explain what a table is. Table, and a table has a key. So we're going to make it U64. and the data in which we want to store. So for now, let's call it election because it's going to be storing the individual elections in our program. So active, we're going to store the elections that are currently active on our platform. Active elections. Um, active election is going to be U64 as well to show the number of our active elections. So now we're going to have the ended elections, which are elections which have ended in our program. Elections, ended elections. Yeah, going to be U64 as well. So yeah, now we're gonna import. We're going to be importing a table from the Aptos standard library. Aptos standard library table. So we're gonna need the self and table. So the compiler is our friend. If we make any mistake in our program, the compiler is going to draw our attention to it. So for instance, if we try to compile this now, the compiler is going to tell us that the election does not exist. So now we'll have to declare the election structure. So struct election has store. So the has store ability is telling our program that we want to store this election inside our election manager. So we're going to store our candidate, our individual candidate that is going to be contesting on our program. Candidate. Candidate is going to be a table as well. It's going to be a table as well. It's going to be a table as well, which is U64 as the key. U64 as the key. So with the key, we can get the value of what we stored. So we're going to be storing our candidate here, which is also going to be another struct. Candidate. We're going to store candidate count. That is the amount of candidates in our program. Candidate store count. It's going to be the type of U64 as well. We're going to store the registered candidate as well, so we'll know if a candidate is registered or not. Only registered candidates will be able to contest in our program. Registered candidates. And we're going to be storing the address of these candidates in a vector. So if you're coming from other programming languages, a vector is just like an array. A vector is just like an array, but it's expandable. In Rust, an array is not expandable because it is not actually. So registered election candidate is going to be storing address. So we're going to give the type the one storing it, address. We made a mistake here. So you can see how efficient the Supra IDE is. So we're going to be storing the total votes, which is going to be type U64 as well. So we're going to be storing registered voters, the voters that registered for the election. Any voter who is not registered will not be allowed to vote. Registered voter, which is going to be U64 type as well, is active. Is the election active? If it's not active, it means the election has not started, or is going to be type of boolean. It means the election has not started or has ended. Election name. So every election has a name. So yeah, we're going to declare the name as well. It's going to be type of string. Sorry, type of string. Type of string. So I'm not a fast typer, so you have to be patient with my mistakes. So it's going to be string. Type of string. It's going to be string. Start time. When the election is going to start. Start time. It's going to be an option because not every election has an immediate start time. Option. Yeah. Option. Type of option. U64. So thus going to have the end time. End time, which is option. Option. U64. And election owner, which is going to be the person that owns this election. So everyone can come, election owner, everyone can come and own an election in our program. Owner, election owner, store his address. And lastly, we need to have a winner. Every election need a winner, so we need to have a winner address. Winner underscore ID, sorry. Which is going to be option. Option. Yeah. Option. U64. So yeah, we have our structs, election structs. We have a candidate count, registered candidates, total votes, registered voters, is active, election name, start time, end time, election owner. So yeah, so we declared candidates here. It's supposed to be candidate because we're going to be storing individual candidates on our program. So we'll come and declare the struct here. So struct candidate struct candidate. It's going to have the abilities of drop and store. So this is going to have the ability of dropping too. After someone created an account, it will drop for another person to be able to use the structure as well. So that's why it has the has drop ability and has store ability because we actually stored it on the election structure. So we're gonna have a name for the candidates, election name, which is string. String. We're gonna have candidate ID, candidate underscore ID, which is going to be U64. We're going to have candidate address to be able to distinguish our candidates by their addresses. So it's going to be address. We're gonna have the DAO in which our candidates represent. Probably party, you can call it whatever you want. String. Going to type string. I'm gonna have an image string. I'm gonna have the votes, the amount of people who vote our candidate, is the amount of votes. So we'll call it votes. Going to be type of U64. So now we have the structure for our candidates. So now let's have a structure for our voter. For our voter has drop and stop. So our voter, we're gonna have just his address, voter underscore address, voter underscore address, gonna store his address, and has voted to know if he has voted. It's going to be bool, either true or false. So we made a mistake here. Yeah, we can actually compile our program to see if we have a mistake. So you see, just make sure you always check your compiler, because your compiler is your friend. Sorry, because the compiler is your friend. Always compile your code to see if you have a mistake. So voter has drop and has store. So has voter must be in capital letter. All your struct must start with capital letter. You can see it has been compiled successfully. So now we can move to start writing our program. So let's start by creating a public function. Public entry function. So the public entry function, public entry form. So the public is telling our program that this function is going to be public, it's going to be seen by everyone, and the entry is telling our program that this public function can actually be triggered by an external program. It might be an API or whatever. So without this public entry, you can never access this function. You can call it election, and we're going to have parameters that we need. We're going to need election owner. It's going to be the person that signs this is going to be the signer. The person that signs the transaction is going to be the owner of the created election. We're going to have an election name, which is going to be string and start time. Start time is going to be option. Remember, it has to be exactly the type we wrote in the structure. So it's going to be option, option, option type 64, sorry, u64. We're gonna do the same for end time. So yeah, these are needed parameters we need in our function. So we're going to be telling our program that we want to acquire election manager, because our election will be stored in the election manager globally. So we're telling our program to acquire the global manager. So we're going to collect the address of the owner's address. Let's collect the address of the owner, equals to signer. Also, know that your function will be invalid if your first parameter is in the signer. So your first parameter must always be the signer in your Supra move programming. If not, you're going to be getting an error called invalid function or something. I forgot the exact name of the error, but make sure that your election owner is always at the first. Invalid, sorry, signer, address of signer. So this is going to help us collect the address of the signer. So it's from the election owner. Which is, yeah, correct. So let's compile and see if we're doing the right thing. So acquires, yeah, we call it you never acquired yet, but we will acquire it in the future. So we want to assert. Shortly, I'm going to explain what an assert is. Assert. So an assert helps us to break the program. It helps us to stop the program if our condition is not met. So it's just like an error, but a controlled form of error exists. Election manager. So we're going to check if the election manager exists in our address, which is the owner of this program. So every resources in SupraMove is being stored in an address. So we're going to access it from our address, in which we're going to be deploying this our contract in election board. So you can see election not initialized init election not init. So when we're writing an assert function, we are telling our program that wherever is from here to here must be true. Our condition must be met here. If our condition is not met, then the program will throw this error. So this error will be a constant. It's going to be a constant. So I have my list of constants already read. I have my list of constants. I have my list of constants already written, but you can name your constants wherever. But personally, this is what I do. So already registered is going to throw 0, which is the constant, and a constant can never be changed in a program. So these are the constants you are going to be using in our program. So as we use them, you're going to see. So an error constant can be whatever number you want, so it doesn't matter. So I just feel like writing them down to make the video faster. So we forgot an important part, which is initializing our function. Every function must be initialized. Sorry, every smart contract in Supramove must be initialized. So public function n3. So initializing it is storing our program on the blockchain so we can start accessing the data in it. Public entry from initialize admin, which is going to be the owner of our program. Admin signer, she's going to be the person that signs the transaction or the account. So let's admin address equals to the signer. So collecting the signer's address of signer admin assert. So we're going to check if this election manager has not been initialized by this account. So there's a not. So this our condition must be met. It must not be stored in our address. So it will be stored. It's going to throw an error. Admin just say E already initialized. So we're going to be moving our program, our stored data to the blockchain, which is going to be in the admin wallet. So every resources in Supramove must be stored in an address, in an account, whatever you want to call it. So I want to send it to admin struct. So we're going to be sending move to. So we're going to have total amount of people. So total amount of created election, the amount of created elections. Going to be a table, just like the way we wrote it in our struct. So we can see a table, active election, ended election. So all is going to be globally. So new. So it's just that means it's going to be default and empty table. So to expect incoming tables that is going to be created in that particular struct. Active election, the amount of elections. So we're going to give it default of 0. Yeah, made a mistake here. So next we're going to have ended election, And these are going to be data that can be accessed globally, data that is going to be accessed, gotten from all the election that is going to be created on our program. Smart contracts, elections, ended elections going to be 0, number of elections that ended. So yeah, let's compile and see. Ended election, restricted ended election. Yeah, no mistake expected. So you can see, as I always say, the compiler is your friend. Do not make the compiler your enemy. Always compile and see wherever you do. Missing field ended. So we can come see sometimes you might have made a typographical error. Ended elections, active elections. So it might be a typographical error. Active election. Ended election. Yeah. Ended election. Okay, it's ended elections. So you can see typographical error cause an issue in our program. Invalid action table new. So new is a function for what to put our parentheses. Yeah, so we can proceed. So getting this error because we actually acquired our program without using it. Yeah, because we acquired manager without using it. So let's go on. Let election manager be called. So we're going to borrow it mutably. Borrow global mutably because we're going to mutate it. Mutation is a syntax that says we want to change something, and election manager, we just don't want to access the data, we want to access it and actually write in it. Manager. Let election ID equal election. So let's get the ID of the election dot ID. So from the total amount of election created on the platform, we want to use it as our ID because every election is going to increment the total election. So yeah, we can get our ID from that. It's just a programming logic. So we can compile our code now. You can see um, election manager was never acquired. So you can see that it's cleared because we actually acquired it here with borrow. So let ID, I think we're missing something here. Okay, let ID equal using equality sign. So made a mistake here by setting our variable. Election election manager. Okay, election election underscore manager. Election manager. Compile. So yeah, we have a minor error, but over time it's gonna get fixed. Election total created elections. Let's see. We're definitely making a typographical error somewhere. I think those the missing. Yeah, so mostly typographical errors. And for now, we ignore these warnings because most of them are just shouting because we haven't used some variables we declared. Election ID. So let's process let's process the time because we are going to be using the Unix time, which is the time frame that has been counting since 1970 till date. So we want to get access to it so we can actually use the Unix time programmatically. So say let's start time equal, we want the elections to be in seconds when our users input the election time. So it's going to be in seconds. And sorry, let's process time. Let's process the time that is going to be passed in the parameter processed. Start time equal if if option is so. So this checking, this is a function on a option that checks if the data is being passed into the option. Start time, which is our parameter. Start time. So you can always hover on it to see the function definition. It returns true if the data is actually in the option. So you can have let start equal to, so because it's a reference to the time, so we have to dereference it by using the start. So if you're coming from other programming languages, you might not be used to the time. So you might not be used to the term deref. So you might do as well to read the basic fundamental of the Rust. That's what I did. Or you can go to the Supra documentation to actually read the documentation. But if you want to follow my path, you can feel free to actually you can feel free to go and read the basic fundamental of Rust programming in the Rust book. So I will actually add that in the description below. Timestamps in seconds. So we're going to get the current time in seconds. Let's the main start time that we're going to be using, which is the process time, is equals to time is equals to start plus the current time. So the number of the seconds is going to be incremented on the current time in the Unix time frame. So we're going to assert main start is not greater is greater than or equal to current time. Just equal to if so we assert if you should always check the main function must be greater or equal to current time. So now we're going to give the sum the value, so some value of main start else is going to be none because the user did not impute the time. So it's going to be none. It's going to be none type of use64. So you can just do the same for end time. So process end time is going to end process end time if to end time equals to end time and option start time is sum. Just copy option start time is sum. So just say let's end time, let end duration. We're going to count the duration. So let's end duration equal option borrow end time. End time. We're going to collect the current time as well. So we already have the, let's clean this out. Let's clean this out. Let's just clean this out. So duration let's mean start. Let me start equal option. I have to borrow from processed time start. Let main n equals to main start plus the end duration. So let the main start plus the end duration is going to give us the final processed end time. So you can always assert for end time main underscore end is greater than our start time. Should be impossible. Sorry, you're gonna assert main n. We're gonna assert main n should always be greater than start main start, which is the process time. Main start. So error underscore end before time is going to assert. So option else should be known as well. So we can actually compile to see if we're making a mistake somewhere. Let main start 88. See, made a mistake here. Compiler is always your friend. It's always your friend. Let me start 98. 98, let me start option. Option borrow. I forgot to write borrow. So 89, we made a mistake as well. We haven't imported our module, our time module. So let's go back to the top and import the necessary modules you're gonna need. So we're gonna need use from Supra framework, time stamp. We're gonna need use Supra. We're gonna need an event in the future to emit some of our events. And yeah, for now we are good. So let's compile our code again and see which error we're getting again. So mean start is greater than equal to current time. Okay, let's see. So yeah, mistake means start or time. And process time start. Process time start somewhere. You know, should we see the typographical variable person compile? Hello. So we're having a typographical error. Let's move on. So where did we stop? Processed start time of processed end time. And now we are going to so now we're going to write. So let's write. So let's determine if the election to should start at the beginning of creation or in the future if the creator wants to start it. So start time is equal to timestamps in second. Let is active. Is active. It's equal. Don't forget, is active in our election struct. Can always go back to our election struct to see when we declare a variable. So at time, anytime we did that. So now we are going to is active, which is a boolean. Okay, it's active. If if option if option is some if option is some process time to option is some process time process time starts. We can just copy it to avoid typographical error. Process time and option is some. Processing time. If it's some, she's going to return boolean. So we're going to say let start is equal to the option borrow. Gonna borrow it. I like to copy it not to make mistake in typing it. Okay, borrow start time. Let end equals to end equal deref option borrow. So we now say current time. If current time is greater or equal start and current time is less than or equal end time equals to end. It should be true. If this condition is met, it's going to return true. And when it returns true, automatically it's going to be active. So let's write an else. Statement else if option is not on process time, that is process time does not exist. Process time does not exist. And option is non process end time. Let's return a false. If any of this is not available, let's return false. Else return false. Compile, always compile, check for errors. Very good. So now let's send. So now let's election. Let's create our election. Let's election equal. Bring in our struct. Let's make use of our struct. Election pass in a candidate, which is a table. It's going to be a new table. Because so it's going to be new table because we want to present a new table for the candidates to fill it themselves. We don't want to put any data in them. So this is going to be 0 as a default. You don't want total votes to have the hard-coded data. So candidates count is the amount of candidates we have in our platform. Should be 0 as well. And what else? Registered 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 voters for the election is going to be in the table as well. This table is going to be new because it is a new because it's a new election you are trying to create. Is active is going to be passed. Is active is going to pass based on the condition we declared earlier. And registered candidate registered candidate is going to be an empty vector as well because it is new. We don't want anything to be in it. It's going to be address. Sorry, it's going to be type of address. We're going to need election name, which is election name as well, so we can leave it as election name. Start time, process start time, end time, end time. It's going to be a mistake here. Equals to it's going to be processed end time, and then we have election owner. Election owner equals to owner's address, and yeah, we need a winner for each election. Every election must have a winner. It is option for a start. Option none. Let's compile and see if we're making mistake anywhere. Expected new. Yeah, got you. Compile. Election new. Register. Connecting for the key for generic. Try provide. So you can see we made some mistakes. Table new. Infer the type parameter v. Or infer the character registered voters. Registered candidates, registered voters. So yeah, it's a mistake. Registered voters is going to be Type of table. This table type is going to be type, or it's going to be table address. Going to be type of address. So a key of address, we type and then voter struct in there. So that should fix our problem. So it's active 22. Okay. Candidates. So it's supposed to be new as well. Candidates. Candidate count. Missing field for candidate count. Q1 2022. Let's see 22 Boolean. Compound here. All candidates. Oh, capital letter C as well. Compiler is your friend. Register candidate expected name to follow. Braces 130. Registered candidates. Error. Expected name followed by brace. Enclosed, less power brace enclosed. And yeah. Drop. Connection does not have the ability to drop. So where that coming from? The car variable still contains a value does not have drop ability. Coming from the car variable selection still contains a value. So yeah, still contains a value. So we'll have to make use of this value. It cannot be dropped. So table add mute election manager dot elections dot elections elections election ID, election ID, mm, election, election manager dot total dot total created election equal election manager dot total created election plus one. So let's see. Expected is struct type in current module got U64. Okay. ET7. ET7. This oh, sure. Yeah. So we're gonna emit some data to the blockchain to write an event that an event actually went on. We created an election. So we're gonna emit out the election underscore ID. I'm gonna emit the election name, and also we're gonna emit the election owner, election owner as owner's address. Also, I forgot to explain the table here. So actually getting the table and we'll add into our election table, election manager dot elections. So if we come to the struct here, we can actually see the elections table and the key and the election. So that's what we did here. So we got the election manager dot the election, and the key is going to be the ID. So whenever we want to access this data, we can use the ID to get this election in particular that our client or user is going to create. So emit it with this struct. So let's create this struct now. Let's create the event struct. Struct as struct. I want to be able to store it on the blockchain. So it's going to be election ID, the type of use 64, and election name, election name, type of string, the type of string, string, um, an election owner of type address. So let's run our code and see if we have a compile time error. Election owner at 150. So here we are. Let's see. Compile again. What's going on? Event. So we have to actually tag this struct as an event struct, else error is going to persist. Event. I'm gonna compile and see. Ta-da! All right. So we just created our create function. Now, all right. So let's create our next function. Let's create our next function. Our next function to register the candidate. So public entry from register candidates. Register candidates. All right. So we're gonna collect some parameters. Candidate underscore address. Going to be the signer. Name. String. String. So in which the candidates represent string. String as well. We're gonna have an image, which is going to be an IP, which is going to be an IPFS string URL. And we're gonna have an election ID to specify the election. the candidate is contesting. It's going to be U64, U64, yeah. So we're gonna acquire election manager. Wherever we do, that is going to need variable. Let's candidate underscore address equal signer address of signer candidate. Assert exists. We're going to check if our election manager exists. Election manager in the deployer address it doesn't exist. Sorry, if it doesn't exist, yeah, we are gonna error not initialized. Let's election underscore manager to global mute. Gonna check if our election contains the ID. We're gonna check if the election contains. We're gonna check if the election the candidate wants to contest for is available. So if it's not available, if the election is an invalid election, we're gonna assert that um, contains election underscore manager dot elections comma election ID. Let's let's election let's election equal table borrow mutably, borrow mutably, in the election manager, in the election store manager dot elections. Election, election ID. See, output compiles. Right, so election, okay, borrow the election mutably. Let's assert if election already has a winner, it means the election is over. So no need of applying to be a candidate anymore. Option, option, is some, sorry, option is none. If the option is none, then it's okay. The election is still active and there's no winner yet, so can apply. Content election 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 dot winner underscore ID. Okay, so assert again. The vector, which is the list of our candidates, not contains, not contains. So we have to make sure that this candidate is not registered already. Election dot registered underscore candidate. Okay, candidate underscore address. This is the address of the signer who wants to register. And yeah, so you can always hover to see the method in which the contains the vector contains. So it expects at least a reference of a vector and also the data in which you want to reference in it. So we want to check. So if our condition is not met, we will have to assert, we have to throw an error already underscore registered underscore candidate. So can compile. See, we made an error. Always consult your compiler not to make some typographical error. Okay, so election dot candidate underscore ID, or let's say underscore count, is equal election plus 1 plus plus 1. Let candidate underscore ID is equal election ID, sorry, equals election dot election very equals to candidate underscore count plus 1. Sorry. So we're going to be using our candidate count to generate our candidate ID. So for each candidate we register is going to increment by 1, generating our candidate as well. So vector, I have to push it now to the election. Push back. I have to push it to our so we'll have to push it to our election dot register vector registered 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 underscore candidate and candidate address. So pushing the candidate address into the vector. Compile. Okay, good. So let's construct our candidates. Candidates equal called candidate struct called candidate struct name as passed by candidates candidate ID candidate address candidate underscore address as the newly collected address candidate the DAO is passed by the candidate, image, and votes. So we're gonna get the election candidates from our struct with the candidate ID, and uh then the candidate struct. So we are passing it into the table, the key, which is the candidate ID, and now the candidate in which we created. Candidate. So include candidate address. Let's check. Check. What type of physical error here? So let's compile and see which error we have again. Candidate. Candidate ID. Candidates. Missing field for let's fix this guy. Missing argument for votes. Missing argument for votes. So I think we use the term votes instead of votes. So sorry, I just sent error again here. All right. Yeah, so let's emit an event that we have registered a candidate. Call it candidate. Sorry, candidate register reg event, which is gonna contain the name of the candidate, candidate underscore ID, and candidate address, candidate underscore address, um, as candidate address. Lastly, I'm gonna image the DAO as well. So now I'm gonna define, I'm gonna declare our structs. Okay, struct. Have a name of string thing candidate underscore address. It's going to be address, type of address, candidate underscore ID equals to view 64 dot string. It's gonna be string. Have to declare it as an event as well. Made a mistake. Fast off. Good. So now I'm gonna move. All right. All right. So we're gonna create a register. All right. So we're gonna create a register voter function. Public entry register voter. So gonna have two parameters in it. One is the voter's address, voters, voters address. It should be type of signer. Election ID the voter wants to register for, which is U64 as well. Okay, so need of that. So we're gonna acquire the election manager, acquires election manager. So let's get the voter's address. Let voter underscore equals signer count of voter underscore address we're gonna assert so now we're gonna check if the voter already exists. So now we're gonna check if the election exists. We're gonna check if the election exists. So contains the election 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 dot election manager dot election elections. So we'll check if the ID is correct. So election ID will be passed in the parameter. Gonna check if it exists. If it doesn't exist, it doesn't contain it, we will assert election not found. Election not found. I think I made a mistake here. Election not initialized. All right. Let's election equal the table guru mutably election score manager dot elections. You want to borrow this ID, election ID, election, and yeah. We want to make sure that our election doesn't. We have to make sure that our election doesn't have a winner, because if it has a winner, it means the election is over. So no need of registering for it. Option is none. So reference election dot winner, election dot winner underscore ID. So you can always check these functions to know how to define them properly. Check, right? Check the voter's address. Sorry, yeah, wanna start already has a winner. So if the winner is none, it means there's no winner yet. But if election.winner has a value, it means it has a winner, and that is the election should be over. So election winner has, it will cancel the program and says through the error of election has a winner. Okay. Lastly, we want to check if the person has already registered, so no need to register again. Our program will stop him from registering multiple times. So table, let's borrow the table. All right, let's check the table contains contains election dot register underscore voters on the table in which we stored our voters. So voters address. So if this voters address is found, it means our condition in the assert has not been met. So to throw an error, and the error should be already registered voter. Right? So Now we're gonna create our structure of the voter. We're gonna pass in the value of the voter structure. So voter underscore address to voter has voted. As voted should be false since it is since it's false since the voter hasn't voted yet. So get the table. Let's add our voter to the table in which we store our voters. Add connection dot registered underscore voter, comma, passing the voter address and pass in the struct or defined voter. So let's see. All right. So event. Let's emit our event. Event emit. We'll define a structure later called voter reg event. Voter reg event. And voter underscore address is to has voted false. All right. So let's declare our structure, our voter registration field. Event. Structure candidate as drop as stuff. Uh, as voter underscore address as underscore voted vote. Right. Define our struct. Check. Successful. All right. Next, let's create our vote function. So it's going to be a public entry as well. Public entry function called vote. So we're going to take in the voter's address. It's going to be a signer. Election ID is going to be U64. Candidate ID is going to be U64 as well. And now we're going to acquire the election manager. Okay. Always want to check if our election manager exists. We want to assert exists. Already did that. So and check if the election exists. Table contains if it's our election manager. Let's get our election manager. So we want to check if our election exists. Let me check if our election exists. Election manager. What elections? So next, we want to check if our election. Next, we want to check if our election has a winner. If it has a winner, it means our election has ended. So it's gonna be option when our certified election is active. If it's not active, we'll throw the error. Election. Election is not active. Where's the syntax? Good. Now, now we are going to check if the users are registered. So assert we're going to check our registered table in the election. Registered voters. Passing the voters ID. Passing the voters address. So you can see the contents will pass the reference of the data in our table and the key of the value we are looking for in the table. So the reference of the value in the table and the key. So you can see that's why we are passing the reference of the table, which is the register table in our struct, and then the key to get the exact table that we are looking for. So yeah, Supramove is amazing. So throw an error if the table does not contain the voter's address. That's error voter not registered. All right. So just going to compile and see if we're doing the right thing. So now let's check if the candidate we want to vote for is available. We're just going to get the candidates table as well. Candidate con contains candidate contains election dot candidate. The candidate ID that will be passed by the user is what we want to check for in the candidates table. So if it doesn't contain it, let's assert and throw the error invalid candidate. So you need a valid candidate that is registered our on our smart contract. So let's voter let's get the voter so we can actually manipulate the data and the voter. Borrow mutably election dot candidate. Passing the candidate ID and yeah. Sorry, we're gonna get the voter election dot registered voter. Let's go voters. What's in the address? Voters address and let's assert. Gonna assert throw an error if the voter has already voted. So by default is by default the voter dot has voted is false. So I'm gonna try an error already already voted already voted. So whenever has voted is true, it should throw has voted. It should throw the error has voted. So yeah, make the compiler your friend. Make the compiler your friend. Always compile. All right, so let's candidate. Let's candidate equal table automatically as the reference of the table, a new table reference because we want to change something in it. Election dot election dot election dot candidate. Election dot candidate ID, which is the key of the candidates. All right. So we're gonna change path. Voter dot pass underscore voted equal true candidate dot vote count. So we want to increment the votes count vote count. Okay, votes, not vote count. Vote candidate dot votes candidate dot votes equals to candidate dot votes plus 1. So for each vote is going to be incremented by 1. So we want to get the election dot total votes for the individual election. The total votes equal election dot total let's call votes plus 1 as well. So to keep track of the total vote in the individual election. So now we're going to emit some data that proves that we actually have voted. So emit. We're going to call the struct that will store our individual emit. We're going to call it boot event. Boot event. We're going to create that struct shortly. So we want to emit the voter's address. Who just voted? Voter's address. So in the emit, you can decide not to send. You can. So in the emit, you can decide not to emit the entire data. You can choose to. You can choose to just pick some data you want to emit out. So we're going to be emitting the candidate the candidate's address that was voted. Sorry, the candidate ID that was voted. And lastly, the election ID. So now we're going to create this struct. Let's just copy it. Just copy it. An event struct. So let's just keep it here. We call it up to put it. I'll specify that this is an event struct. Struct pass drop and also store and yeah. So I think we had let's see the feature we have there. Candidate address, well, voter's address, candidate ID. Let's see voters address, which is address, which is going to be storing address, and candidate ID, which is going to be U64, U64, and the election ID, which is going to be U64 as well. Election ID, made mistake here. Tada. I think we are doing the right thing. So next, we're gonna be creating a function to start the election. So it's going to be public entry as well. Function start election. Election owner. Only the election owner will be able to start the election and to end it. So everyone can come to our platform and own an election. Then every DAO can come to our platform and create their individual election. Duration. Duration, you want the election to end. Duration, maybe in seconds. Duration, seconds. Gonna be U64, U64. And yeah. So let's acquire election manager. Let owners address. Let's get the owner's address equal to signer address of election owner. Elect election underscore owner. Assert. Assert exists. And to make sure our election manager always exists. In the contract, election manager. Election manager. Let election manager equal borrow is equal borrow global mute election manager always compile, always compile, always compile. Right. Let's assert check if our election table contains the election we want to start. We don't want a case whereby the user wants to start an election that doesn't exist, that he hasn't created. So you have to tackle that. Election not found. Right, so let's get to election we want to start. Equal table dot borrow mutably election manager dot elections election manager dot elections and the ID of the election ID that we want to start. In a case whereby the user has already started multiple elections, so this is going to point out to the election we're going to point out to the election he wants to start. So we want to make sure that the election doesn't have a winner option is none. So if it's none, I think there's no data in it. So it means let's pass the option in it. Election dot winner underscore ID e election has winner. So next let's assert we want to make sure that the election owner election underscore owner is is equal to owner's address. If it's not, it means that the person is not the owner of the it means the person is not the owner of the election. So we want to check if the election dot owner we want to check if the election dot election owner is equal to owner's address. If it's not, it means the owner is invalid. The owner doesn't own the election. Invalid. Invalid owner. Invalid owner. Yeah. Let's compile. Right. So assert election has to be active. Election dot active. Election dot is active is true. If it's false, it means election ended. Means election ended or has already started. You don't want to start an election that is already active. Okay, so election, if that condition is not met, so we want to start it. Election dot is active to call true. Election dot start underscore time is equal option some timestamp. Now in seconds, check and let's and in time we call timestamp seconds plus the duration you want the election to last. To the duration underscore like a second. Right. Let's compile. All right. So um election dot and time equal option sum in time. The next, so it's not compulsory to output um so it's not com so it's not compulsory to emit. So we're not gonna emit, just gonna leave it like that. So public, let's create end election, public entry function and election. Election owner. Only the owner can end election as well. Election U64. Okay, have to acquire election manager. Its owner's address equal to signer, the address of election underscore owner. Let's assert. We just want to check if the election exists. So I'm check the table if it contains the election we want to end. So election dot election manager election manager dot elect dot election at election equal table mutably have to make sure the address is equals to the address of the account owner, else we want to assert invalid owner. Okay, always compile. The compiler is your friend, not your enemy. Assert lecture dot lecture sorry lecture is active. Want to make sure the election we want to end is active. You don't want to end an already ended election. So election the election not active. Okay, so we want whenever we end an election, it should calculate the winners. We want whenever we end our election, we should we want whenever we want to add a logic in the election in the we want to add a logic in the end election. So whenever whenever an election ends, it automatically calculates the winner of the election. So we can do this by writing a loop that does the calculation that calculates the winner of the election by so we want to add an additional logic in our end election. So whenever the election is ended, it should automatically calculate the winner of the election. So we're going to achieve this by writing a while loop. So let's winner underscore ID. You want to get the winner of the ID of the winner. We call this is another way of writing your type U64. You just want to use it for reference. So whenever you come across it, you won't be surprised. U64. So let's highest count. I'm gonna use this variable to keep the count. I'm gonna use this to keep the count of the candidate with the highest votes. Highest votes equal 0. Type of U64 as well. So now let's I equal 1 because our candidate's ID always starts with a 1, so we want our loop to start from 1. So I'm gonna say while I is less than or equal to can candidate sorry equals to election dot candidate count, which is the amount of the candidate that are registered in our platform. So if table contains with each iteration we want to check if the table contains the candidate the I, which is the ID. So let's candidate equal table dot borrow. Since you are not mutating anything, we just want to check the candidates. We are not going to use borrow mutably. We just want to check the candidate election dot candidate election dot candidate. I want to grab the candidates, the individual candidates, and write an if statement. If candidate dot votes is greater than highest votes, the condition is true, then we want to take highest vote equals to candidate dot votes to change the highest into the current count to make the candidate the current highest candidates. So we take his winner, we make winner ID his ID. So whenever this condition so whenever this condition so it keeps iterating until this condition are met. So if this condition is met early, um so it keep iterating until this condition are met, and also this condition in our while parameter make us keep the while in control. So now we're going to say if winner underscore id is greater than 0, election dot winner underscore id is equal to option from winner underscore id. We want to make sure that we always have a winner. So if winner id if winner id if so if no candidate is found, then so if winner so if no election winner is found, we just set it to none. So definitely we'll always have a winner if the election actually has votes. So let's say election dot is underscore active. Let's change it to false, and election and election election manager dot ended election in our global election manager election ended underscore election, call it election underscore manager dot ended elections. Elections. So we want to always increment the election manager and the election globally with 1 to keep track of all the election that was created on our platform. So we have an error here. Candidate count. Why candidate by election dot candidate count? Okay, let's see. We have an S here. Okay, right. All right. So now we're going to start writing view functions. So view functions a function that doesn't manipulate anything in our smart contract, but we can use it to view some data in our election. So you have but we start by tagging the function as a view function. So have to be public entry, so everyone can have access to the data. Public function, sorry, not entry, just public function. Public election info public election info. We'll have to give it the election ID, the election we want to get with info. Election ID is going to be U64. So now this statement is what so this is an expression, and in expression we always have to write out the so this is an expression. So in every expression we need to write out the data types of the so this function is going to be an expression. So the body of this function is going to be an expression. So we have to write out all the data type we are expected to get after calling this function. So we're going to be expecting a string, maybe expecting a string, a boolean, an option, and also a U64. So we have to acquire election manager as well. Election manager as such. We're going to check if our election exists. As such exists. Our function is expecting the return of our expression. So now let's return the expression. Election underscore manager. So we cannot borrow mutable, we can only borrow global because that is a global data. So write the election manager type from manager election manager election underscore board. Getting this error because we haven't sent out the expression we promised our function. Okay, table. So now we're gonna send out the data we promised our expression, and it's in form of tuple. So if you don't know what the tuple is, you read about it. It's just like an array, but it stores data of different types. Um, so election dot election election underscore name election dot is underscore active. Election name string, election is active, boolean, and the next is going to be an option. Election dot start underscore time, election dot end time, election dot total underscore votes. All right, so let's compile. Election name expression. Let's see. Getting getting this error from invalid expression list of 5 lengths, boolean option. Okay, so we have another option as well. Let's copy this. So it has to be exactly the type that we're expecting and the same order. Yeah, we're good. So The next, we're going to create a view function that check. We're going to create a view function that checks if a voter has voted. So it's also going to start with a view tag, view uh, public function um, has voter underscore voted election underscore ID going to be used 64, and the voters address is going to be address. So we're gonna be expecting a bool type because it's an expression. Acquires election manager set. And now we're gonna say if tables the table contains election but registered registered underscore voters, comma voters address as the key. Automatically to return false because they haven't voted. So now let's see. Let's voter equal table election dot regis voters plus voter underscore address. Now return the voter dot has voted. All right. All right. So we're gonna write a view function to get all the candidates that registered for an election. View candidates. Gonna call it get all candidates. Get all candidates. Gonna pick parameter of election ID. We're gonna return them all in a vector. So yeah, so vector we're gonna call it we're gonna pass in a struct called candidate details. We're gonna create that shortly. Candidate details requires election manager. That's assets lists. So let's say let candidate equal vector vector should be empty for now. Empty vector type of candidate. So let's create this struct. So call it struct candidate details as store as struct. Gonna have candidate name, candidate ID, use 64. Gonna have a name, set of string name, candidate underscore address, and the type of address, the DAO, level, and then image, image, type of string. So I'm gonna be using an IPFS URL in the string format, and then lastly the votes of the candidates. Votes use 64. Right, so let's see. Let I equal to 1 because our candidates always start from 1. Why? Because our candidate ID always start from 1. Why I is less than or equal to election dot candidate count if table contains election dot candidate I. Let's candidate equal table role. Let's push every individual candidate into the vector. Vector push back back reference node table candidate candidate details, pushing the candidate underscore ID or candidate dot candidate ID name equal candidate dot name candidate address underscore address. Candidate dot So for each iteration, we get the candidate ID, then we come to the table, we use the I as the candidate key. So when we get the key from the tables, we actually gotten the candidates. So now we can destructure the candidates into the candidate details and push them into the vector. So now for each iteration, we're gonna say I equal I plus one, I plus one. And then we're gonna be sending candidates, which is this vector as the expression expects. So let's compile and see. We'll get an error while expected equal candidate count. Okay. Try parameter. Okay. 277 selection candidates. Selection dot candidates. See and compile again. Looking for a value from generic function. But sure. And do this. Yeah, but one more error. Invalid module access. Okay, see you, I see you. Okay, one more error. Selection, candidate selection. The compiler is always your friend. Com- Always compile your code so you get compile time error instead of runtime errors. So yeah, we are good. So lastly, we are going to be writing a function to get the election winner. So let's see, it's going to be a view function as well. View public function gets underscore winner or election underscore ID use 64. The expression is going to be expecting a type of option. Option 64. Right, so requires election manager. Let election underscore manager equal global And always note, whenever you are returning an expression, you don't have to put a semicolon. If you put a semicolon, you will get a compile time error. Let's see. You see invalid return expression. So you're always mindful of that. Yeah. So from now, our smart contract has been written fully. So we're gonna deploy and call the functions to see if they work properly. So our our contract has been compiled successfully. So now let's deploy this contract. So first of all, we're going to accept a few sets. You can see it's received 5 Supra, and we have Supra in our account. You cannot deploy without a few sets to the testnet. So let's click our deploy button. Build successfully, deployed successfully. So let's 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 so here we can see our first transaction, recent transaction. Let's come to interact function. So we can just come and select our wallet here. So here's the type of view. You can view all your functions here. You can run your functions here as well. So yeah, let's come to run. Let's click on the run button, and here we'll select the contract we created. Initially, we created the function as we, initially we created the function as initially you remember we called the contract voting contract, so we can see it. So in the wallet here, you can have many contracts, as many contracts as possible in the address. So we are just going to select the one we created, which is voting contract. So whenever you create a smart contract, you have to initialize it. So we're going to start by initializing, and you can always follow through to see if our transaction went through. Transaction successfully. You can see function we called initialized. So next, you don't like this. So next we're gonna create an election. So if you remember in our function, the parameters for create function has start and end, and they were all optional. So if we decide to go with a start time, when we decide to start the election immediately, we might just put 0 here according to the function we created. So for now, we're just going to go with the none. And this parameter is for the end time, but for now we're just gonna create the election with the election name. So we're gonna call this let's call it Supra CEO. I'm just going to create it. Let's see our transaction. Yeah, transaction went through successfully. Create, can follow through. See, we created the argument was Supra CEO, and it has been created with the election ID of 0. So we can come to view function and view election information 0. So you can see the election started with false, and a lot of data we are going to see later. So now next let's come and register a candidate. We're going to do that in the front end. Let's do that in the front end. So yeah, you can interact with your function as much as possible here. Let's register a voter. Let's to the parameter is 0, which is the election ID. We can register this wallet as a voter. You can come see our function. We can see our we just registered the wallet as a voter. So yeah, you can see the house voted is false, and the address of the person that registered as a voter. So yeah, you can choose to start the election, but we're going to do that in the front end. Okay, you can decide to check. So yeah, in the next section, we are going to interact with all these functions from the front end. So let's get it. GM. So for the sake of the length of this video, I'm going to be showing you how to integrate your smart contract into the front end. So let's get it. So I expect you already know what a class is. If you don't know what a class is, you should go and read about class. So these are the interface, the type that our so this file is just like the API that connects our front end to the blockchain, just like traditional Web2 API. So exactly that's how this works. So first of all, I started by writing down the interfaces. We're going to see how we implemented the interfaces as well. And then I imported the Supra client from Supra SDK and also the BCS. So I'm going to explain the BCS as well. And also in the voting configs, you can see it here. It entails our smart contract and our module name, the module name we created in this by the right side, which is our smart contract, the voting contract, the module name here, voting contract, and also we got our network address here. So the testnet, so we have to specify explicitly that we are sending the transaction to the testnet. So within the on-chain configs, you can name the file whatever you want as well. So the on-chain TS is just like the API as I said earlier. So let's see how it works. So first of all, I created a class, made the client private, so it cannot be accessed anywhere apart from inside this class that we just built. So from here, from any other file, we cannot access the client. So read more about the class. So we got the constructor as well, um, a new Supra client, and on the always on the voting always on our Supra client is always on this network, which is the testnet network. So also I imported a file called conversion utils. So this conversion utils is attached in this file, but I could as well attach the GitHub URL as well, so you can get access to it. So basically, what the converter does, it uses the BCS converter. So the use BCS conversion utils helps us to serialize some of the data type we would like to serialize, but then we're going to see it in action and we're going to understand it better. So I imported it, so it will also be attached in the GitHub file. So do not worry, you can also get access to it. It will make your life easier. All right, so we created transaction payload, and this is how our transaction payload is going to be. So if you want to read more about the transaction payload, you can go to the Supra documentation and see more about it. So it's just simple, the function name, app type, and the app. So now we're gonna make use of the transaction creation in our class, and also it is private. You can see it as well. So private async. Um, so this is how we're going to send our transaction to this Taki wallet. We're going to see it in action as well. And yeah, one of the most important thing here is your transaction expiry time. If it's more than 30 minutes at times, sorry, if it's more than 30 seconds at times, you might get error as well. So as I said, you can also read more about it in the Supra documentation. So the account gets the account of the sender, index 0, which is your first account on your Stacky wallet, the sequence 0, and the voting contract, the voting contract is from the on-chain configs. The voting module is also in the on-chain config, so you can always refer back to them. So yeah, So this is how our data is being sent to create transaction and the raw data is being passed. So let's see how all this is being utilized. So first of all, we'll start with our function that is called create election. Create election. So the we can see the needed by the right side. We can see the parameter that is being expected from the parameter that is being expected in our create action. So we can see the parameters that are expected from us, which is election name, start election, and end election. So we can see election name, start election, and end election. So we made promise that in return we are going to be having a string. So this string is going to be our transaction hash. So whenever we send an async transaction to the Stacky wallet, we expect something back, and the promise we're expecting is a string, which is our transaction hash. So we're going to try to send our try to build our argument. So BSC.realize string, it tells the 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 blockchain, it tells the Supra blockchain that we are serializing the name a into a Supra into. So the BSC.serialization.strings converts our normal string from JavaScript from TypeScript or JavaScript into the data type that the move understand, because it's just like someone speaking French and someone speaking Germany, they need an interpreter within them in the middle to translate to the both sides. So that's what the BCS does. It translates some data types that the move might not understand. So the move might not understand the string from TypeScript, so we have to explicitly convert it the from the normal string into the serialized string. So we did this as well. These dot conversion utils from the file I showed you earlier. We got the serialized option U64. So we serialize the normal number data type into the serialized option U64. So you can see how we do that to convert this data type that the move will understand. So as I made the scenario earlier, as I used the scenario earlier to explain how these languages interact with each other. So that's how we build our argument. And mind you, our arguments need to be in the same order that it is on our smart contract. Election name, start election, and end election. If not, you're going to be getting an error back. You're going to be getting an error. So that's the same thing we did on our register candidate as well. So we serialized them, and then we have promise of a string and return, because when we are returning, we are awaiting. So we are waiting back for this promise. So and we can see them. So now I want to there's a very important part I would like you to see. So this gets election information. To get election information, we expect the data type of election info. You can see it here, this type, election info. So we expect a name, a return, is active, a start time, end time, and total time. So we are expecting that data type as a promise. So we also built our transaction payload, and we are awaiting the data type to promise. So when we await it and we get hold of it, so now it's going to be saved in our return. So when it saves in our return, the the election name is going to be in a string. So what I always do is that I always console.log. I always console.log it to let's see. I always console.log it to show I always console.log it to see how the data structure is, how nested it is in an array or something. So what I did here is that the first index of the let's see how it looks. Let's see how it looks. So so test raw election. Let's see if we can find it here. Test raw election. So this is how the raw election is. Um the first is the first result index by, you can see, look at my, focus on my cursor. As you can see, the first index is the election name, and we got it. It's active, it's false, we got it just by the index. So you have to learn how to console to log this stuff, so you can know the right data type you can get access to. And one important part I want you to understand as well is that the the option type is always returned in. One of the important part I want you to understand is that the option type is always returned as as a vector, or as an the option type is always returned as a vector. Sorry, the option type is always returned as an array. So you have to access what is inside. So the option 64 will not come as a number, or as a type of U64. So as a it always come as a vector that you have to access the data inside the vector, just like an array. So we have to do vector dot the index of 0 to get the main start time. If not, you're not going to get the start time. So that's a very important concept you need to understand. So we did that as well. Results dot vect, then the index of 0 to get the the data that's inside an option. So option 64 or whatever option it is, it comes in the vec, and you have to access what is inside so you can be able to use the data. So that's what we did here. And yeah, those are the important parts you need to. So you can just go through it and you understand whatever I did in the documentation. So let's see how I imported them. Let's see how they are being used. Just explain few parts of the front end. So yeah, let's see. So this was the previous contract I built. So we can just copy the main the main contract address we built in the video. So let me show you how to do it. You just put it here as a contract. So this was the contract. This is where our smart contract is being stored. So we put it here. So the previous address was one of the contract I built before this video. So if we refresh now, we're not going to see all this data again. You can see. So we have to create our election ourselves. So some of the data in our front end were hard coded. So I'll expect you to actually try it out by making this data dynamic instead of hard coded. So we're gonna start by so let's explain how to create an election, how we did it. So create an election. First of all, we just do some certain checks and validation. Check if there is an account. If there's not an account connected, return please connect your wallet. We just did some validation, but here's the main part of the function. So whenever we are creating we created the state, whenever we click this button, it will set the transaction is loading through. So it's going to show below, it's going to show when that is true, it's going to set transaction is loading. Sorry, where is that? So whenever we click our handle create. Whenever we call this function, handle create function is going to set, first of all, it's going to set this transaction loading into true. So in our element, in our element below, is going to, we use it to actually show that we, so below I used it to show that our transaction is actually loading. So we are waiting for a data from the blockchain. So waiting for a data from the blockchain. So that's what I did here. So it's just a state, a use state I use dynamically. So you can also trace it and see how it's been created. So it's gonna set another status into creating election. So we'll go down and see how they all work. So from our so this is how we did from the on-chain services dot create election. On-chain services dot create election. Where are you? Yeah, so we can see how we called the file on-chain service dot create election. We can see how we called the file and how we passed our data. So this data is we use an input so that sets this variable from a state whenever we type it's an event listener, so it updates this create election. So it updates this create, so we can see it here. So you can see it's an event listener. So whenever we type the election name, so it's actually update itself. So it actually updates itself. So whenever we type it, updates the part of the code with the variable. So whenever we are done typing, so it stores in this create election. So if you understand the basic of React, you understand whatever I did here. Same goes for the start election, which is going to be a number, and end election as well. So that's how I dynamically um used it. So after we send this transaction, we can see how it will send this function we create to the blockchain. So in return, we are going to be waiting for a transaction hash that we are going to display, that we are going to use to set transaction status into this transaction hash, and that we can use to display it wherever we want. Let's see. So transaction status, let's see how we use it to. So we can see how we we used it here. So whenever our transaction return and hash, we display it here on this div below this anchor tag. So if you are patient and you follow this flow the way it is on this the way it is on this on this the way it is on this the way it is on this so if you can be patient and follow this so if you can be patient to follow this So if you can be patient and follow this flow of how I built this platform, you definitely understand whatever I did here. So it has been well labeled, so it will be very easy for you to move around. And then yeah, that's it. So another thing I used here was the Pinata. I used the Pinata to actually send transaction to the to the Pinata server to save it as an IPFS. So if you want to understand about the Pinata, you can also read their documentation. I will link I will drop a link to the Pinata documentation as well. So yeah, let's let's use our app. So first of all, let's connect our wallet. Um, Wallet is connected. Okay, let's switch to testnet. Let's switch to testnet. It has been switched to testnet. Election name, can choose to go with Supra CEO. Let's assume Supra always let's assume Supra let's assume Supra always does an election for the CEO position after some period of time. So you can Remember the start time and the end time are all options. So we don't need to explicitly define them. So we can just see our args here, our argument Supra CEO. So we can choose to create. So you can also choose to scan and see how our transaction went through. So transaction successful. And then let's see. There's another hard-coded data I used in this use effect. Let's see our use effect. That displays the election information. Yeah, you so get election. Let's see our election ID. Our election ID is 1. So get election information. Let's get ID of 1. And yes, we have this ID of 1 as well. You can also see all these functions are having ID of 1. So we can always refer back to our smart contract to see what in particular are we sending as a parameter. So we can see our transaction successfully. We got our transaction hash back just as we were awaiting. So let's register. So let's register Joshua Topkin as also a contester of our election. So I think here, so we can just submit it to Pinata. Yeah, for we to use Pinata, we have to make sure the server is up. So let's use the Pinata server npm run dev. So yeah, let's upload to Pinata. So uploading successful. So we can see our upload URL. So we've gotten the URL of this. So it automatically sets the image part of our register candidate. So it automatically sets this link, this IPFS link into the candidate image IPFS link. So it's going to be sent to the blockchain directly. So you can as well check how I did all this. So for the election name now, we're gonna which election are we applying for is election ID 1. Candidate name, Josh, the contester, just say Josh is representing a DAO called Josh DAO. So yeah, we can register him as a candidate. Let's do that. Let's check if our argument is well built. So we can see the Pinata URL here, our IPFS URL, the DAO and everything well arranged. So we can always check our transaction hash, but it's already successful. Let's refresh and see if our candidate will reflect. So we can see Josh has been registered. Let's register. So remember in our contract, one wallet cannot register more than one time. So let's use the second wallet. Let's use the second wallet to register Chase. So wallet connected. Register. Let's register Chase as a candidate. We send to Pinata to get our URL. So it has been created successfully. The election we want to contest for election number one, name cheese is representing the cheese style, and then create candidate. Candidate. So, oh, the reason why we are getting this error is because our wallet is on the mainnet, so we have to make sure that it's on the testnet. So switch to mainnet. So switch to testnet. I don't know why my wallet is also connected. Switch to testnet. So let's try it out again. All right, so you can see our data has been reset, so we have to redo that. So let's upload to Pinata. There's ID, name should be chase, representing chase style. So let's view, yeah, got our image. So let's register candidates. So yeah, candidates registered. So you can refresh and see. So both registered. And lastly, let's register John. So let's register John. So election ID 1, candidate name John, representing the John that we can upload to Pinata to get our URL. So and register. So we have to change our wallets. Let's change our wallets. Disconnect. Let's connect with John wallet. Connect. And connected successfully. So let's upload to Pinata again. Set. Most of these data are hard-coded. So I expect you to show your expertise by making them dynamic. Presenting John, name John Dow. So register as candidate. So we have to make sure that our wallet is on the mainnet, is on the testnet. So testnet. Let's refresh. All right, so John has been created as a candidate as well. So let's set our wallet into the owner's address. So only the owner has the power to create and end an election. So, so let's start the election so we can vote. Sorry, let's register wallet as a voter. Let's register our wallet as a voter. Register as a voter so we can vote. Only registered accounts, wallets can vote. So this same wallet is the owner of the election. So duration is always in seconds. So let's just make it 300 seconds. So you can start the election. Remember, we used Unicode. So we use Unix to set our timestamp. Wow. So let's start the election. Election number 1, time 300 seconds. Let's see. So election has been started successfully. So let's vote. Let's vote. Let's vote. Let's vote. Let's vote. All right. Personally, I'm gonna vote for Josh. So let's go with that. Voter not registered. All right. Let's register voter. All right. Voter registered. Let's vote. Let's vote for Josh. So I was having an issue. I was having an issue ending the election. So I was having an issue ending the election because we failed to control our loop in the end election function in the smart contract. So I had to control the loop here. So now let's end the election. Joshua Topkin is ahead with 1 vote. So let's end the election to see who's the election winner. Election, let's end the election. Election ID 1. Let's see who's the winner. Who is the winner of the election? All right. So let's end the election. And let's refresh. So you can see Joshua Topkin is the winner of the election. Let's go. So yeah, um that's how our platform works. So let me show you how we got this winner icon here. So what I did was that in the on-chain TS, which is just like our API, I I if you remember, we wrote a function to get the election winner. So where are you? Get election, yeah, get election winner. So when we get our election winner, we get the value of the ID inside of the winner, which is an option. And I told you earlier that the options come as a vector. So we get the vector, we get the ID. So we get the content of the vector with 0. And so that's how we came here. So I think we used use effects. Let's see, get winner. Yeah, we use an use effect to get the winner of the election ID. So when we get it, we set the election winner ID to the winner we got from the blockchain. So here it is. So we set the state. So with this state now, we got the states. We got the state variable here, and that's how we used it to display the election winner on the right. Election winner. So that's how we built our platform from scratch to finish. a full stack Supradapp, not just a dApp. So if you like this video and you want to buy me coffee, I'm going to link my address. So if you like this video and you want to buy me a coffee, I'll drop my address below the description. And also there is some parts I want you to implement by yourself. So you has voted. I did not implement it in the front end, so you can play with it. You can find somewhere in the front end and implement has voted. And for the Pinata, I will drop a link to Pinata so you can go and learn how to deploy images to Pinata. Thanks for watching my video. Do it to like and subscribe. I'll be dropping more of this type of videos. Thanks for your time.